Hi, it's Wednesday, June 3rd, 2020. My name is Noah Seeley, and welcome to my channel. So today I have two LeetCode questions that I did earlier today. Both questions are coded in Python 3 and related to linked lists. It's been a while since I've worked with linked lists, so I've certainly reviewed a lot of good material today. For those who do not know, a linked list is a data structure such as a list or an array, but its elements are not overseen by a larger data structure like an array. Instead, everything is managed at the node level. So as you can see here from my little pseudocode document, each node will typically store some sort of data and also holds a pointer to the next node that would kind of fall into the list. So technically, there isn't actually a list. It's just a bunch of nodes pointing to the next node until there are no more nodes. So we can see this little sample data structure for a linked list and how a linked list kind of compares to a normal list. So we see a normal list is kind of comma separated and all together, whereas a linked list, you can see these individual nodes simply point to the next node until there are no more elements in that list. So with that being said, let's go see what questions we have for today. So the first question was of easy difficulty, and it involved merging two sorted linked lists together. As you can see from this code on the right here, it's a pretty simple algorithm that will run in big O of n plus m time complexity, where n and m are the two list sizes respectively. So as we can see here, we will compare the two currently selected nodes, adding the smaller one to the new list upon each iteration. When one list no longer has any nodes, we simply append the rest of the other list to the new linked list. Once again, this is allowed because we know for sure that both lists are already sorted. In the end, we return the new list.next. This is because the list was initialized with a dummy variable of 0 that we can see right here just to get the list going. Thus, the list that we want to see is stored after this dummy variable of 0. This dummy variable of 0 can also be referred to as the head of the list. Like I said, I was pretty rusty at first with linked list operations, especially in Python. So I used another solution from LeetCode from user Amal171 as kind of a reference. This solution will also be linked in the description below. Moving on to the next question, this was a medium difficulty question that dealt with swapping pairs in the nodes of a linked list. Basically, for every two nodes found in the list, we would swap them. So as you can see here on the right, the algorithm typically used for swapping two elements is that you set a temporary variable equal to one variable, say A, set the other variable that you are not holding equal to that original A, and then let that other original variable equal that temporarily stored variable. And like I said, this visual should kind of show how that works a little better. So the algorithm basically works like that, but because we are dealing with a linked list, we add another part of it that lets us cycle through the rest of the list and kind of keep on with that continuity. So the code kind of starts making sure that there's even anything in the list, and if there's not, we just return nothing or just the first element if there's only one element in that list. So the next steps are kind of the confusing part of the algorithm. So I have a little diagram here that should help us understand it a little bit better. So if we start with this list, 1, 2, 3, 4, which we can see here in the test case, once again, the code is on the left and the visual is on the right. We're going to set the current node to 1 here, the temp node to the next node from current, which, as you can see here, cur next will equal temp. For now, they'll equal the same thing. And then we have this temp.next, which is just the next node from temp. And we're going to start the algorithm off by setting prev or previous to none. So first we set cur.next to temp.next. So if we remember that this temp will be 2, but this cur next will now be 3, and this is kind of how the linked list will look like. We then put the cur variable inside the temp.next. So this one we have here will now go to here, and then the head, which equals current, will equal temp. And if we remember the temp equaled 2 from way up here before where temp equaled 2, we can see the cur or the head of the list will now be 2. And we can see that line comes from if prev is none, which it is in this case, head will equal temp. So now that brings us on to the next iteration where all of the same thing will kind of occur, and you'll see how this kind of all wraps itself together. So basically everything's going to move up. The temp, we're going to remember, is equal to 1. We have this cur variable there too, and then the respective next variables. So like the previous iteration, we set cur.next equal to temp.next. So you can see how this used to equal 4, and now it's being moved right there. So then we can see that temp.next is going to be set to cur. So cur is 3 will now move to temp.next. And then we can see here on the left that if prev is equal to none, that's not the case here. Prev is equal to cur. The prev.next is equal to temp. So that's what we're going to implement right here. And if we remember way back from up here, temp was equal to 1. Thus, where we have prev.next right here, we'll now insert temp into there. So that spot, which is actually technically cur, but also prev.next will now equal 1. and then that will end the algorithm. So for this example, there are only 2 iterations. As you can imagine, with larger lists, there'll be many more iterations. It kind of follows that same algorithm, which is from the basis of this swap function found here. So we have 2 solutions that we can use. So the first solution, I had help with a article here from TechieDelight. It's a bit more like what I explained. And then the second solution is just the same, but in reduced number of lines of code. And that comes from a LeetCode user named Yi15. So both of those solutions should work, and I'll link both solutions that I talked about in the description below. And yeah, that's it for the questions today. This concludes my review of those 2 linked list related questions. As always, I've included any resources that I've used in the description below for you guys to check out. If there's anything you feel that I've missed or something that I got wrong, please feel free to comment it down below. That's all for today. Thanks guys for watching. See you tomorrow.